Hello and welcome to today's webinar, the building blocks of telco transformation from Total Telecom. With me today there's Ronan Kelly, who's the Chief Technology Officer, EMEA and APAC region from ADTRAN, and Michael Dargue, the Principal Consultant from Cartesian. Ronan brings over 20 years experience in the telecoms industry, and as well as his work at ADTRAN, he's currently the President of the FTTH Council Europe. Ronan's worked with some of the world's largest operators and is currently working with ADTRAN, a global leader in the Sdn and SV field, on software-defined access. Michael also has over 20 years experience in the telecom sector and has worked both sides of the fence with previous roles at Colt and Nortel Networks. At Cartesian, he works at the intersection between technology, finance and regulation. Now, without further ado, I'm going to pass it over to you, Ronan.
Great, thanks Rob, appreciate the introduction there. So good afternoon everybody. Great to have the opportunity to share with you our views on the building blocks of telco transformation. Just by way of agenda for today, I want to focus in on some of the key elements that I believe fundamentally will influence telco transformation in the near future, and ultimately will determine which operator is bathed in success and which ones are being consumed in the pool of consolidation that we expect to see happen across Europe in the coming years. To begin, I want to talk about some of the forces that are shaping our market currently. I'll then move on to talk about some of the tools that telcos have at their disposal to address these forces. I then want to speak about software-defined access and why it's critically important to embrace the opportunity afforded by fifth-generation access network investments to become an SDN-ready operator. And in closing, I want to speak about the concept of the network as a platform and what that can really mean for service monetization in the future. So to kick things off, I want to talk about the market forces, and in particular the gigabit market forces, which are already beginning to shape the telecoms landscape throughout the world. There are a number of different forces at play here. I'll start off by talking about the operator forces. And if we look at the chart that we see on the screen, what this chart gives us a view for is the impact that happens when an industry that's ripe for disruption is disrupted by a challenger, a new entrant into the market that has sufficient means to change the landscape within the market. And what we see over on the left, just above 2011, we see a little blue dot, which was the first launch of Google Fiber in a US city. And then each subsequent blue dot that we see on this chart is the launch by an operator of a new residential gigabit service in a city, a major city. Now, most of these on this particular chart are based in the US. You'll see one or two European representations there, but most of it's US based. We'll talk about how this is trickling through now into Europe as well. We also have the government forces at play, and we see on the screen there Commissioner Oettinger, and Oettinger really was critical in driving the latest draft proposal for the Electronic Communications Code, or the code as it's known in short, which is currently working its way through Parliament and ultimately is targeted to be enshrined into law either at the back end of this year or within the first quarter of 2018 is what the latest news that we're hearing with regard to that front. While Oettinger himself has moved on in his brief, where he's transferred over onto a financial brief within the Commission, Vice President Ansip has taken up the work that Oettinger started and is pushing through with the same focus and the same mission towards a gigabit society and a gigabit economy for Europe. If we think about for a second the impact of those changes, ultimately what it'll result in is gigabit connectivity being made available for all socioeconomic drivers. So whether it's transport hubs, whether it's universities, whether it's libraries or schools, even your local bar or restaurant, your hospitals, your hotels, every single place of work will be connected with gigabit connectivity. The net impact of that is roughly around 10% of premises in every country in Europe will be connected with gigabit connectivity. So that's going to have huge implications, first of all, with regard to all the other premises that will be passed by that infrastructure to connect those premises. And secondly, the consumer's attitude with regard to connectivity. If I can get a gigabit connectivity down my local bar, then what are my expectations going to be when I go home to use the broadband connectivity? I showed earlier the previous slide, not the previous one, but the one before that, the spread of gigabit connectivity once a disruptor entered into the market and started to offer gigabit services at consumer price levels. We're also seeing a positive impact now in Europe, as I mentioned earlier, where each dot on this screen is the launch of a gigabit service in a city by a particular service provider. And we can see the proliferation across the whole continent now is really gaining pace. This particular chart that I show is actually about a year old now at this point. If you go to gigabitmonitor.com, you can get the very latest statistics on gigabit connectivity. And there's no shortage of investment occurring across Europe. So really the foundations are being put in place to provide that vision of gigabit society as we go forward. We also have the consumer forces. And with the consumer forces, we've got an interplay between the consumer electronic manufacturers and the application developers. It's fair to say that consumers themselves very rarely choose to use more bandwidth just for the sake of using it. In reality, what happens is their usage patterns are altered when they acquire a new consumer electronic device or they start to interact with a new application. If we think about some of the things that are involved in this interplay, I'll give you some examples, some recent announcements in the press. So for example, live streaming, which was once the preserve of the technical groups within society using applications like Periscope and Meerkat, live streaming suddenly got democratized to the entire population, where applications like YouTube and Facebook natively supported live streaming this year. So we see the announcement on the screen there where YouTube added 4K support for live stream. We also see then on the consumer electronic side of things, the device on the screen we have there is a wearable, and that wearable has its dedicated camera built into it. You wear the thing around your neck so you don't have to sit there holding your phone up if you're at a football match or a concert or whatever, and it'll automatically stream to your favorite social media application. In a similar fashion, something that we had predicted quite a while back was that we would ultimately start to get 360-degree video capture capabilities into our smartphones. And what you see on the screen there is one of the component manufacturers showing off their latest camera module, which is a front and rear facing 360-degree camera module that can fit directly into the smartphones that we have today. And currently in the APAC market, you can buy smartphones with these modules built in already. So this change is already beginning to happen, where we'll have that capability in our pocket to be able to capture and also to stream 360-degree VR video footage. To complement that, we've got the likes of Facebook, where Facebook earlier this year announced that they now support 360-degree video footage at 4K resolution. So again, you've got that interplay between the applications and the devices. In a similar fashion, we're witnessing the world change in how it interacts with compute resources. And this is a monumental change now. You know, if we think about the generations that have engaged in computing over the last 30 years or so, predominantly they've been interacting using a combination of keyboard and mouse or trackpad inputs. What we're seeing now is a transition towards interaction with the digital world through voice control, and this will be very rapidly expanded to gesture control. Now, the key point is these devices here, they are not hugely powerful supercomputers that can answer every question that we ever dream of. What they are is they're basic compute resources that are deployed at very low cost. The likes of the Amazon Echo Dot on the right-hand side is as low as $30. But what they're augmented by is cloud compute resource. And this trend of augmenting fairly basic things with cloud compute resources is the way forward. We see on the screen now the likes of the Barbie doll, which has recently been augmented by a company called ToyTalk. And ToyTalk, basically, in a similar fashion to the Amazon Echo or the Google Home device, what they're doing is they're augmenting simple devices with cloud technology to change how our children are entertained and how they're educated, etc. And we expect that to transition further as well. For those that are from a technical background, they probably recognize the robot in the foreground there. It's a robot that's the culmination of 20 years of R&D effort by Honda, one of the world's largest companies. And that robot, Asimo, is a largely autonomous robot. It can walk around in strange environments. It can navigate things like stairs and other obstacles like people and pets, etc. And it can communicate. The challenge you've got with ASIMO at the moment is the cost structure. ASIMO carries around the equivalent of a supercomputer on its back, and that has a knock-on impact on its cost. Currently today you can't buy ASIMO, but you can lease them, and to lease them costs about $100,000 per month. So you get a sense of just the overall cost of the solution. That will never be democratized so long as we burden robotics with those sort of cost structures. And this again is where the cloud comes into play, where the cloud compute resources will allow those very high cost resources to be shared across tens of thousands, if not millions of users at the same time, so that the cost of the equipment then is reduced down to things like low-cost sensors and motors and controllers out on the consumer side, which will then help us realize the vision that we've been promised for many, many decades now, that, you know, in the year 2000 we'll have robots that will do all our manual labor for us in our homes, etc. So, you know, these are stepping stones in that direction. And then finally, we've got the cloudification of everything. All software as we go forward, the concept of buying software, installing it locally on a PC, and that being the end of the commercial relationship, those days are gone. You know, we've been talking about software as a service for over a decade now at this point, and most of the primary applications that people use today have significant portions of them that depend on cloud connectivity at any given point in time. And that's a trend that we expect to continue until we've got to the point where desktop install software becomes a thing of the past. One of the things to note, of all the things that I've shown on the screen here, all of them are available today, but also what's very important is all of them depend very heavily on high quality and low latency upload capacity. And that's something that we'll touch on later on when we begin to talk about the different broadband connectivity options that are available as part of 5th generation access. We also have the media forces that are at play within the market. And the media forces is really the enrichment of all media that's being pushed out to consumers across all platforms. What I show here on the screen, particularly across the top there, is multiple different devices. Everything from your large screen TV to the latest tablets from the likes of Samsung, Sony's latest smartphone that they launched earlier this year at Mobile World Congress, Primac's latest VR headset, and you know, you've got augmented reality headset as well on the screen. And the key point with all of these is these devices are all 4K or ultra high definition today. So the concept where network planners have been planning for, you know, one large 4K screen in the sitting room and maybe a few high def and standard def TVs for streaming and a little bit of activity on phones and tablets. The reality is, in the modern household, you know, within the next year or two, we're going to see many, many simultaneous streams at 4K resolution, and that resolution would also continue to rise, and that's going to be driven out of the ever-increasing need for higher resolution with both augmented reality and virtual reality. We see the image towards the middle right, where we show 4 different views of VR footage. And for those of you that have had the opportunity to try things like the 1st gen Oculus Rift or the HTC Vive, once you got over the initial fascination of how responsive it is, you all probably remember the fact that you could see each and every single pixel on the screen, and it kind of took away from it being a true virtual reality experience. The human eye sees in 12K resolution, and with a 120-degree field of view, you need 3 times that to get a full 360-degree seamless panorama. So if you picture that, you're up at about 30 to 40K of resolution before the human eye will truly be tricked into thinking that it's proper virtual reality. And of course, all of these have knock-on implications with regard to bandwidth. Finally, we've got Nielsen's force, and Nielsen's law, where he predicted basically for lead users that we would see 50% growth year on year. To be fair, Nielsen's law is tracking reasonably well. If you look at the dotted line, particularly the green dotted line up towards the top, that focuses in on the services, the leading services targeted towards those lead users in the industry, and it's tracked Nielsen reasonably well. Within ADTRAN, for the last 10 years or so, we've also been accumulating data from multiple different sources whether it's Sandvine reports or the Cisco VNI index, etc., and combining all of that data to create a consensus view with regard to what users are actually using on the network. So where they might be buying a 100 meg service or a gigabit service during the busy hour times, what is the average usage? Now, one of the things to keep in mind, it's very important that we don't overlook that these are heavily average charts, so they don't show the peaks. But what they do show is that even on average, the usage is tracking very closely to Nielsen's prediction as well, which is very important for capacity planning in the future. So the next section focused in on what we refer to as fifth generation access. And it kind of begs the question, what is fifth generation access? And if we look at how we've engaged with the internet from the get-go, you know, the very first generation was really, you know, it was a dial-up period for the vast majority of users. We then moved on to second gen, which was really, you know, it was predominantly ADSL1. It was all about being always online, as opposed to having people shout up the stairs saying, "Get off that phone," or "Get off the internet, I want to make a phone call." In third gen, we moved towards things like super fast connectivity. So, you know, services in the order of about, you know, 20 to 30 megabits per second. And really on the mobile side of things, it starts to become about connectivity when we're out and about. As we move on to fourth gen, which is arguably where we're at today, right at this moment in time, it's really about ultra fast connectivity. So sub 300 meg type connectivity, particularly in the urban areas. Technologies like vectored VDSL2 or DOCSIS 3.1 on the cable side of things, GPON on the fiber to the home, some XG-PON 1 out there, but very little. The mobile side of things is really about a mobile broadband experience. So it's not just about barely being able to get online. You can actually do stuff like streaming, etc. now when you're out and about. What fifth gen is really about the gigabit society, and it's the technologies that will allow gigabit services to be delivered to the masses. The key point is, with fourth gen technology, with technologies like GPON or DOCSIS 3.0, sure, I can deliver gigabit connectivity to one or two customers on that shared PON or that shared cable segment, but I can't do it to the mass market, and that's where we need to move on with the technologies. So on the cable side of things, we shift towards DOCSIS 3.1. On the copper access side of things, it's towards technologies like g.fast in a fiber to the basement or fiber to the DP type deployment. And the PON technologies are where we're seeing a lot of change now, a shift towards 10 gig EPON for the cable industry, XGS-PON and NG-PON2 for the telco industry. And then on the wireless side of things, we're seeing big changes in Wi-Fi with the likes of Wave 2, 802.11ac, but also in the fixed wireless access space, big shift towards millimeter wave technologies, whether it's 28, 37, 60, or 70 to 80 gigahertz millimeter wave fixed wireless applications. We've also got 5G coming over the hill, and then there's the low Earth orbit satellite solutions as well. So huge amount of activity going on in the space. The service implications for fifth gen are quite important as well, because it's not just about the tenfold increase in bandwidth that we expect to see, but there's also other big implications around things like symmetry. If you look at all the leading 5th gen technologies, they all bring symmetric capabilities or close to symmetric capabilities to the table. So you got the likes of the PON technologies, all the next gen PON technologies are symmetric by default. You've got g.fast, where g.fast can be statically configured as a symmetric technology because of its TDD capabilities, or it can participate in a symmetric-like experience using capabilities like dynamic timing allocation. And then with DOCSIS 3.1, it's recognized within the DOCSIS community that upload capacities are becoming increasingly important. So DOCSIS full duplex, while it doesn't get to full symmetric experience, it does improve significantly over the typical 10:1 type ratios that we see in the cable world today. Latency as well is hugely important. So all of these technologies are moving you into the order of low single-digit latency, which will be critical for applications like VR and AR and, you know, remote control of robotics and so on and so forth. Also, service robustness is hugely improved with the low train time that we see on these new technologies, where technologies like vectored VDSL could take anything up to a minute or more to train up if you took a hit on the line. With the likes of g.fast technologies, you're down to probably about 2 seconds on the line. And then finally, and I'll touch on this more later, all of these technologies are SDN ready today. With I'd say most of the vendors out there, but certainly the key vendors that are leading the whole shift towards software-defined networking, they're able to support NetConf, Yang, and OpenFlow, etc., in their key solutions in this 5th gen family of products. I'm going to focus in on the copper access technologies for a little bit as well. So, if we look at the evolution of the copper access technologies, what we've really been doing to drive capacity is we've been using more and more spectrum. So where ADSL started out at 2.2 megahertz of spectrum available to use on the copper lines, today with the g.fast deployments that we've got rolling out right as I speak to you now, they're right up at 106 megahertz. And what will start to roll out now in 2018, the Amendment 3 of g.fast, will double that capacity again and move things up into the 212 megahertz range. So really very, very high frequencies. But when you start to use those very high frequencies, the distance you can send those signals is significantly less than what you could do with the lower frequencies. So it means the equipment needs to be located much closer to the users. We've also got the capability of dynamic timing allocation that I touched on earlier. So with dynamic timing allocation, rather than statically configuring my g.fast line to have a particular ratio, whether that upstream downstream ratio is 50-50 or 80-20 or 90-10, instead what we can do is sense what the user is trying to do, and then on a real-time basis we can adjust that ratio without interrupting the service so that the user's needs are addressed. So if the user, for example, is trying to download heavily, we can adjust that bandwidth so that he gets more download capacity. And then if he shifts into an activity that requires more upload capacity, we can shift it again back in the other direction, so he has more upload capacity made available to him. The key point is this is not service interrupting, and it can happen in the order of milliseconds. So the user is unaware that what he's doing to achieve a symmetric-like experience of gigabit connectivity is shifting his upstream downstream ratios. He's completely unaware of that. Basically, this happens in a very short order, and the user feels like they have full gigabit connectivity upstream or downstream whenever they need it. We also have, thanks to g.fast, increased versatility. So traditionally, the telco technologies like VDSL were run over twisted pair. With g.fast, we can move them over coaxial cables as well. So this chart that I show on the screen, the rate reach chart, shows the performance, the rate reach performance in, if you look at the horizontal scale, the top number is in feet, the bottom number is in meters. The rate reach performance of both 106 megahertz g.fast over twisted pair, that's the TP, or over coax. And what you can see with the coax connectivity, right out to distances of 500 meters, you're getting gigabit connectivity. So for even the very largest multi-dwelling units that you would seek to deploy in a fiber to the basement configuration, if you have access to those coaxial cables, you can comfortably deliver gigabit symmetric type experience to your users. Where this becomes really important is for off-net locations for the likes of the cable industry, where they may have access to particular buildings that might have coaxial cables within the building, but they haven't extended their DOCSIS network out to that point. What they can do is they can deliver IP services, so IPTV, etc., on a either fiber-based backhaul or a leased capacity type backhaul, or even a fixed wireless backhaul, and then use this as an in-building technology rather than building a dedicated CMTS, which is quite expensive. They can use this g.fast technology to deliver the services. The innovation hasn't stopped either with 212 megahertz, so we've got activities going on within the ITU today that see the g.fast performance rate, particularly on coaxial cables, where they're looking at speeds of up to 10 gigabits per second using 848 megahertz at distances of up to 100 meter. So again, inside MDUs, this is a fabulous technology. Now, where we see this really being targeted towards is more for backhaul type activities. So I might have a more traditional g.fast DPU being backhauled by this capability, or I might even have a small cell or a Wi-Fi access point being backhauled by this type of technology. It'll be a while before we're bringing 10 gigabit per second, in a dedicated fashion into the users' homes. We also see on this chart here that performance when we do it over twisted pair. And over twisted pair, you're looking at throughput rates in the order of 4 gigabit per second at distances of about 40 meters, or 2 gigabit per second at distances of about 100 meters. So again, as a DP type technology, very powerful. On the fiber side of things, there's a big focus towards moving towards the next generation PON technologies. And one of the debates that's raging at the moment is whether people start off with fixed wavelength technology like XGS-PON, which helps drive down the cost for that initial transition, or whether they move over to NG-PON2. On the fixed wavelength side of things, there's a few initiatives going on within the industry, things like Class G optics, for example, which allow us to not only deploy XGS-PON using the original 1577, 1270 wavelengths, but we can also reuse the GPON wavelengths, particularly in greenfield deployments, to further lower the cost of those initial fixed wavelength connections at 10 gig symmetric. So we can use that 1490 receive and 1310 transmit in a lower cost transceiver and still deliver an XGS-PON 10 gig symmetric service. There's also dual mode optics making their way through, where with dual mode optics we negate the need to have an external coexistent element to combine both GPON and XGS-PON. Instead, we do that inside the transceiver and launch both services from within the transceiver, again helping to reduce cost and space required to launch those combined services. On the NG-PON2 side of things, I think ultimately over time we will see NG-PON2 become the de facto within the industry. The challenge at the moment is the cost of the tunable transceivers needed within the ONTs. So in the short term, we see it being pretty much the preserve of either enterprise connectivity or backhaul applications for other access technologies like g.fast DPUs, like fixed wireless devices, or even more traditional MSAN devices. And then finally, we also have the shift towards millimeter wave for both backhaul and access technologies. So I mentioned earlier everything from 28 to 37 to 60 gig type technologies, and also 70 and 80 gigahertz technologies. One of the key things that we're seeing a strong pull for is the need for, because of the very short distances that the higher frequencies can go, you're going to end up with a very dense wireless environment. And there's a strong focus towards self-optimization within that environment, so that you can almost, I don't want to say plug and play, because it really takes away from the technology that drives these things, but it does allow for much more of a plug and play type environment where radios can be deployed and then communicate amongst each other to find the optimal path forward. At the moment, there's a strong focus in this around a 28 gig space for backhaul applications, but we will see 60 gig applications start to make their way to the fore in the coming year for access applications. So that brings us on to the next section, which is around software-defined access. So with the software-defined access side of things, really the focus is towards, as these investments are occurring in these fifth generation technologies, we know within the industry that there's been a lot of innovation going on with regard to improving how networks are deployed and managed and how services can be delivered. And there's a window of opportunity now as we make these next rounds of investment in fifth generation access technologies for us to embrace that and walk away, when we've done that fifth gen deployment, that we're walking away from that with a network that's at least SDN ready. If we're not ready to turn on SDN control today as a service provider, that we've at least built a network that is SDN ready for when we do make that decision to turn on SDN control. What I talk about, particularly with regard to SDN in the access space, SDN has a couple of key principles within the access space, and some of those principles are around disaggregation and modularity. So on the disaggregation side of things, what we're trying to do on multiple fronts, we're trying to move away from the traditional monolithic chassis-based systems. And instead, what we're trying to do is move towards an environment where everything's interconnected with standardized Ethernet. The traditional proprietary backplane that would exist in a chassis-based system, that backplane is now replaced by standard Ethernet switches. So the backplane is now an Ethernet environment. And the line cards, which were traditionally proprietary line cards that connected into that proprietary chassis and backplane, those line cards are now essentially media converters between Ethernet, which they use to connect to the Ethernet backplane, and whatever the access technology is that's facing out towards the customer. So if that's XGS-PON or NG-PON2, it doesn't care. It's doing a media conversion within what's now effectively a pizza box. We're also virtualizing, where it makes sense, a lot of the network functions that were ran in the control software in that traditional chassis system. They're now being virtualized, and they can be run either within the cloud in a commodity off-the-shelf server environment, or if it makes sense, some of those virtual network functions can be located on the access network equipment directly, or right down on the customer premises equipment as well. So there's a lot of flexibility and mobility now being afforded to service providers so they can pick the optimal place to locate services. This disaggregation also makes its way through to the software environment, where the software environment, we're moving away from the monolithic big block of code where every feature is intertwined. And when you get a new code release, you've got to retest every single function within your network. Instead, we're now moving to an environment where it's a microservices type environment, where each feature, each capability is a discrete application, essentially, that interconnects via API to all the other applications. This is an environment that we're already familiar with our smartphone type environment, where, you know, when we get upgrades to applications, we just upgrade the apps that are requiring the upgrade. We don't have to replace the whole operating system on the device. This has huge impacts with regard to the amount of interruption that happens when new services are rolled out. It has massive implications for the testing cycles that are required to verify functionality when rolling out new code, because now we have to test significantly less functionality to launch new services. Ultimately, where we're trying to move towards is, if we take all of those components that I've described, we're trying to move to an environment where we're leveraging best-in-class open SDN controllers. And you know, if we look at the leading ones in that space, particularly coming from the development community that's supported by the operators in an open source type fashion, we have the likes of ONOS and Open Daylight in that space. So leveraging with those SDN controllers and taking that control plane and moving that into the cloud, and then at the data plane down towards the bottom, we have what I described earlier, where you've got an Ethernet leaf spine switch architecture, and then I've got my media converters out at the end that are doing that conversion from Ethernet through to the whatever access technology is available. And the key point is, all of these are available today. These solutions, the hardware that's involved in this, the software that drives them, is all available today, and some of which is already being deployed in service providers' networks as we speak, with live trafficking customers, you know, in commercial deployments. So, you know, the wheels are already in motion towards this new architecture. If we look at the scalability that this can afford us as well, and particularly in a mixed multi-vendor environment, as I described earlier, you've got your leaf spine switches up towards the top, and then you have the scenario where you're adding in the media converters down towards the bottom. And it's really very much a pay-as-you-grow type model. It's a success-based model. So as you add more subscribers and you need to add more capacity, you just add in more pizza boxes and Ethernet uplink them into your backbone. One of the key points, and it's an important point to keep in mind, is most of these elements are all flow switching capable as well. So when you move into a flow switching environment, you can rapidly change the configuration of the equipment that's involved in the service chain in the order of, you know, microseconds or picoseconds even, so that the network can become much more responsive based on the control that's now centralized. So you can begin to make decisions on how users' traffic is handled as it crosses the network on a real-time basis. The other important piece to keep in the back of your mind, we show here vendor A, vendor B, vendor C in the different colors on the screen. If you're adhering to the standardized data models that the likes of the Broadband Forum are publishing, it makes it much easier for you to slot in different vendors into that environment than the traditional days where you had proprietary SNMP, MIBs, etc. ADTRAN as a vendor, ultimately where this is pushing us towards, we've developed our Mosaic portfolio or our Mosaic platform. And with Mosaic, we're conscious that not every service provider has the skill sets, and more importantly, has the bandwidth or the resources available to be able to take on all the different building blocks that would go into creating an end-to-end SDN controlled environment. So with Mosaic, we've created what would be the equivalent of Red Hat in the Linux world. We're providing a hardened and baked implementation that we've tested all of our virtual network functions and we've tested all of our hardware appliances against. But Mosaic as an environment also has available to it an open development environment where we have a program called MONA, which stands for Mosaic Open Network Alliance, where service providers can bring along their preferred partners and work with ADTRAN, and we can integrate those partners into that open SDN environment and get them operating in that service chain. And whether that's for, providing virtual network functions, whether that's for providing deeper analytics, or even more granular control over the network, there's a huge amount of flexibility available now. This brings me on to the final section. And within the final section, we begin to look at the principles around the platform economy. And you'll be pleased to know this is a fairly short section, so there's not too many slides here. But really what we're talking about within the platform economy, the concept behind it is, if you look at some of the names that we've got on the screen there, companies like Airbnb, companies like eBay, Facebook, etc., Amazon, increasingly lots of these companies, they don't necessarily produce product themselves. What they do is they serve as a conduit to connect buyers to sellers, producers to consumers. So they really serve as a platform, and they generate their revenues. Some of them generate their revenues in a margin basis, for every transaction that goes over their platform, they generate margin. Others generate their revenues through other means, whether it's through endorsement or advertisement, etc. But the key point is it opens up a huge amount of flexibility with how revenues can be generated as we go forward into the future. The implications of this for the telco world, if we think about the telco world today, the current commercial model is all pointed towards the consumer. The consumer pays for everything. Now, whether the consumer is an enterprise or whether it's a residential user, but they pay for pretty much everything. As we move towards the SDN world, and particularly if we've got a network that's application aware and can transition and change on a real-time basis, that opens up new opportunities for us. Some of those opportunities manifest themselves in the likes of what they refer to as user-driven networks. Now, for me, user-driven networks, it's a fine idea, and it's certainly something that we will see much more of as we go forward. But it only barely scratches the surface with regard to the capabilities that a true SDN-enabled, OpenFlow-enabled, software-defined access network can deliver. So if you think about, where consumers can order new services or they can order upgrades and stuff like that, it's great that we can deal with that on a real-time basis, but it really doesn't challenge the network at all. When we begin to think about services of the future, and particularly, when we reminisce about what I spoke about earlier, about everything being hosted in the cloud, etc., we're already beginning to see in, let's say, the games world. The example I got here on the screen is Battlefront. And when Battlefront was launched, it was launched with multiple different editions. Now, most of those editions came with extra features and capabilities that were embedded within the game. But what if, when I'm downloading that game on the Xbox, I have an option to pay €2 or €3 extra to get the accelerated download? And me knowing that my wife and kids are due back in 90 minutes time, would I pay €2 extra to have 87 minutes worth of gaming and have the game down in 3 minutes versus paying the standard rate and waiting 90 minutes for it to download? It opens up new capabilities like that. Or would I pay for the full package, the premium package, so that I can have a guaranteed latency experience across my service provider's network? And these are all things that the providers of cloud-based services, different providers can benefit from different capabilities on the network. And many of those providers, when you speak to them, are more than happy to pay for that capability. Now, they don't want to get gouged on pricing, but they are looking for ways to offer service level agreements to their customers. So as we look forward to the future, the way we see things transitioning is we need the commercial model to shift in a bi-directional fashion. The over-the-top providers of services, and when I say that, I don't just mean Netflix or Amazon. I go back to Michael's point earlier about the rapid growth that we're seeing in the likes of Office 365 and that. That growth would be even faster if Office 365 could offer guarantees around availability and latency when they're selling their services into enterprises and they're trying to convince an IT manager to step away from his local server and his comms room. So there's great scope for new commercial models that the telco community needs to open itself up to, because certainly the over-the-top community are looking for the opportunity to be able to leverage such mechanisms to improve the services that they offer. And that's really where ADTRAN's Mosaic comes into play. ADTRAN's Mosaic ecosystem allows not just through our own solutions, but also the third-party solutions that engage in that Mosaic open access network access program, the MONA program. It allows them to engage in that environment with third-party applications. So to conclude, we've a couple of key points on the screen there, and the key points really stem around how all of these topics that I've touched on today are intertwined. Fundamentally, the gigabit society transition, that underpins a telco transformation. There's a window that's open now that telcos are investing in these next generation technologies that will allow ubiquitous gigabit type services throughout their network. And it's critically important that the service providers, when they're making those investments, embrace that opportunity to, at a bare minimum, make sure they're SDN ready, but ideally use that opportunity to transition to an SDN controlled access environment with immediate effect. The other piece to keep in mind is there's no silver bullet when it comes to delivering on the vision of gigabit society. The reality is we don't live in an environment where we've got ubiquitous fiber. And, you know, if I wear my fiber to the home council hat for a second, I wish we did. But the reality is it's going to take quite a while before we do get to that point. So there are other mediums that are available. We touched on the copper technologies. We touched on the coax technologies. We touched on the fixed wireless access technologies. All of them are going to have to come together in a collaborative type fashion to deliver on that vision of the gigabit society. And finally, open SDN control and orchestration really is the foundation to future service automation and innovation. If we want to be able to capitalize on the services that the over-the-top providers are bringing to their consumers, and if they want to be able to bring those services that have requirements around latency, that have requirements around availability, etc., they need a means to be able to interact with the network and program the network on a real-time basis, and they're willing to pay for that. So we need to start looking away from the more traditional models of monetizing everything towards the consumer and really start thinking about how do we apply this back in the other direction to give the over-the-top guys what they're looking for, but also to allow us as the operator community to monetize the network better. So with that, that concludes today's presentation, and we're going to have Q&A session led by Rob now for the next 15 minutes or so.
We are indeed. Thank you for that, Roland. Thank you. And sorry, we had some technical problems at the beginning of that, but it was very interesting. We've got a few questions here, and I know also that Michael wanted to make some sort of general points, I think, on the Sdn and Platform Economy. So if you want to kick off just briefly with that, Michael, before we look at a couple of the questions.
Yeah, absolutely. I mean, SDN NFE, I mean, it's a huge transformation for the industry, and we've actually just completed a study of what's going on, looking at implementation in various CPs around the world. So Cartesian will be publishing that next month. And it's quite interesting, actually. It very much, chimes with what Ronan was saying. This initial kind of interest in NFE, SDN as a means of saving capex, it's now a lot less important, really, in the CPs that we were talking to. They're attaching a lot more weight to the agility and flexibility that these technologies are going to provide them in the future, and that's both to enable them to automate their own processes, so to remove human intervention, which can cause errors and so on, and will allow them to scale better, but also to enable them to create this sort of programmable communications platform, which they can then offer up to third parties like app providers, or even expose APIs directly to their business customers.
Okay, great. So should we look at a couple of these questions? I'm looking at one at the moment, which says, I guess this is for both of you really to comment on. At the moment, would you say telco transformation is focused on provisioning for digital or digital service enablement? Where should the priority be going forwards? Ronan, do you want to have a punt at that one?
Rob, you wouldn't repeat it for me. You broke up a little bit, and I kind of missed the context of it. Then you wouldn't repeat the question for me, please? Yeah,
sure. The question was: at the moment, would you say that telco transformation is focused on provisioning for digital or digital service is focused on provisioning for digital or digital service enablement? Where should the priority be going forwards?
For me, when I speak with some of the more forward-looking telcos, increasingly there's recognition that the need to cooperate with other providers of services is increasing. I think there's recognition now that they can't hold back the tide of innovation that's emerging from the cloud. So they need to be part of that value chain. And what I'm seeing now as part of the telco transformation, the ones that are really looking further down the road, when they look 10 years out and say, where are we going to be in the value chain for the consumer 10 years out from now? The old model where the telco delivered everything, that model is pretty much gone. Some of the new models with regard to, you know, particularly around media and stuff like that, they're scale games, and some of the telcos will remain in that space, those that have, you know, tens, if not hundreds of millions of subscribers available to them. But there will be a large amount of operators that don't stay in that space, and they'll end up either reselling cloud-based offerings in that space, or they'll end up having to try and monetize the transport of those type services in the future. So really what we're seeing is, I'm hearing back from the telcos, is they're looking for a network that gives them the maximum flexibility, so that regardless of which outcome materializes, they have a network that's able to adapt and adjust accordingly. So that if they do end up having to, you know, just purely be the provider of services, but being able to do that in a way that gives guaranteed experience and allows them to monetize that guaranteed experience, while it's not the most desirable outcome for them, they recognize that it's a scenario that they at least need to have a contingency plan in place for.
Okay, great. Michael, do you want to add anything to that?
Yeah, I think, you know, it's obviously a challenging market. There's a lot of pressure on costs, and there's a lot of competition out there, both from traditional competitors and new entrants. So, you know, we see telcos going through a large cost transformation, and NFV SDN is part of that, which will allow them to become more operationally efficient. But then, as I was saying, once you start bringing in, the software-defined networks into the organization, it's not just a technology transformation. You really need to start thinking about a business transformation, and how do you monetize this new flexibility and agility you have?
Okay, great, thanks. Looking at the future, is it realistic that we're going to have an environment where operators can pick and choose between their vendors to build their networks? You know, do vendors want to play in that space, or is it just something that the operators would want, but it's not in the vendor interest?
I'll chip in if you like. I think operators always picked and choose to some extent, but I think NFV SDN allows them to get a bit more granular about mixing and matching, rather than having a sort of perhaps a prime contractor type deal where you have one vendor providing end-to-end on a certain platform. You can now start integrating point solutions a bit more easily along that. I say easily, I mean the potential is there, although it puts more work on the network operators to achieve that.
Okay.
How do you feel about that?
Yeah, so certainly what I'm observing within the industry, and some of this is there already today. We're seeing some of the larger operators in the world now mandate things like the publishing of the data models for management of the equipment under the new paradigm. So organizations like Broadband Forum, for example, for the management of g.fast DPUs, vendors like ADTRAN have worked with Broadband Forum to help standardize a data model for the management of DPUs. So the principle being, if a service provider develops their management and orchestration around that Broadband Forum data model, and then the hardware vendors that they go to within the industry adhere to that data model, they can mix and match with relative ease, particularly in comparison to the older model where they were trying to manage proprietary MIBs. I think also the position, you asked the point with regard to whether the vendor community is willing to engage in that, because it's certainly an initiative that's being pushed by the operator community. And I think the attitude towards that depends on your position within the market. I think there's one or two dominant players within the market that have very large market share that are less receptive to this, because regardless of the outcome, even if they win a large portion, an equivalent size portion of the new network as we go forward, the value of that is going to be substantially less, just simply because the entrance barriers are going to be much lower and it's going to be a much more competitive landscape. So we're observing with some of the bigger players out there, quite a bit of foot dragging in this direction. Whereas the challengers within the industry, they're looking at this as, you know, it's blue ocean. This is a new opportunity to grab market share. So they're embracing the requirements of the operator because it's lowering their entrance barriers in.
Okay, great. Thanks for that. I think the other thing that come to my mind here, Michael, is you've just done a study, haven't you, at Cartesian on NFV SDN? Yeah, is that focused on the operator market, and what's happening with that?
Yeah, so we spoke to a number of CPs and vendors around the world, and it was really focused on the operational challenges that NFV SDN brought with it. So, you know, we were kind of conscious that there are some technical challenges, you know, and we figure that they will get ironed out. But we were really interested in what happens when you take the technology out of the lab and into kind of into a real world production environment. This is quite interesting, because then you start, you know, encountering problems with or challenges, if you like, with culture and skills, and you know, these people type issues, which are always harder to resolve than technical ones.
Yeah, that's interesting. Now that Ronan resonates with a conversation you and I were having a while ago, and this isn't actually a question from the audience, but I remember you saying to me at the time that you thought that skill shortages was one of the real big things that needs to be addressed in this space.
Absolutely. Any of the service providers that I talk to now, they recognize there's huge potential with this new paradigm as they go forward, but the big challenge they have is their existing resources, while they're rapidly trying to learn as quickly as they can, both from the vendors and also whatever material they can get access to online, but that's going to take time. But also just having the confidence and the know-how to join up all the dots in this and deploy it in a fashion that's sufficiently robust to meet telco requirements, that is a real challenge at the moment within the industry. And that's, you know, that's an area that we within ADTRAN have been focused heavily on now over the last sort of 12 months, is really beefing up our capacity in that front, both internally and also working with external partners, so that we can help the service providers with that transition.
And is there anything specific as to how you could help service providers in that space?
Basically, we can provide the resources, the skill sets, the people on the ground to do the design, the plan, the build, the implementation.
Excellent. Sounds good. Sounds good. And I think really what we need to do now is we're sort of past the top of the hour, so we're over the running time. So I guess what I'd like to say to you guys is have you got any sort of parting comments on this? You know, it's an interesting subject. Everyone's talking telco transformation. So what's the final shot, Michael? Do you want to have a final shot at this one?
Yeah, I think we're just in another very interesting period in the telecoms world, really. You know, we've got the NFV SDN is going to create enormous change for all the players right across the value chain, and coupled with that, we've got this move to the gigabit access, which should unlock a whole load of new use cases. So I continue to be interested and excited by this industry.
Excellent. So we look forward to those use cases. And Ronan, what's your final views?
I suppose the key takeaway for me would be we have moved past the if stage and we're now on to the when stage. So I would urge all of the callers on the call, if they're not already, they really need to be planning how they're going to implement this in their network and what it's going to mean with regard to their service offerings in the years ahead. You know, the ship is already in motion on this thing. There's no question mark about whether it will get mass market deployment in the telco space anymore. I'm seeing it on all sides now. I'm seeing it amongst the wireless operators. I'm seeing it amongst the cable operators and also the telcos as well. It's actually surprising. Cable and wireless operators seem to be far more receptive to this. A lot of the pushing that had to be done in the early days with the telco space, we don't witness that same pushback from those other two communities. So just an interesting observation.
Okay, great, thank you. So I guess that sort of concludes our activity there. I think maybe your comments about technology and how things are continuing to move is probably quite pertinent, since we probably proved ourselves this afternoon that technology can catch us all out at times. So interesting times ahead. So thank you very much, Michael Dargue from Cartesian and Ronan Kelly from ADTRAN. Thank you for taking part in the webinar this afternoon. Thank you to everyone for attending.
Thank you.
Thanks, Rob.
Thanks, Rob.